Green infrastructure means using nature to help manage stormwater and reduce impacts to communities and surface water. Stormwater runoff occurs when rainwater flows over the land surface rather than sinking in. A warmer, wetter world caused by global climate change produces larger rain events, and development creates impermeable surfaces like parking lots, both of which increase runoff. Problem: stormwater runoff contains sediment from erosion and chemicals that wash off plants and soil, like fertilizers and pesticides. Sediment makes water cloudy and reduces light infiltration. This results in less growth for aquatic plants and algae, which are the base of the aquatic food chain. Fertilizer can cause eutrophication, resulting in too much algae. Algae that grow in eutrophic waters are not eaten by invertebrates. Pesticides can harm aquatic life by mimicking hormones, causing aquatic life like frogs and fish problems with growth, development, and reproduction. Pollutants increase the cost of treating drinking water and can cause odor and taste problems. Pesticides can mimic hormones in humans too. How can we reduce sediment and chemical pollution in stormwater runoff? Green infrastructure. We can revegetate stormwater basins with native wetland plants. Basins with native plants are not mowed, and the plants grow tall. When muddy stormwater flows around the plants, it slows down and the sediment drops out of suspension, clearing the water before it flows downstream. Wetland plants absorb fertilizer runoff, keeping excess nutrients out of downstream waters, thus preventing eutrophication. Basin soils absorb pesticides, and soil microbes can degrade some, thus reducing harm to life downstream. At Penn State Berks, we are experimenting with green infrastructure. Green infrastructure uses natural processes like infiltration, biodegradation, and evaporation to help manage stormwater and reduce impacts to communities and surface water. Here is a stormwater detention basin on Penn State Berks campus. This photo from spring 2019 shows a muddy basin where the turf grass has died because of frequent flooding. Due to a lack of vegetation, the basin ponded water and was unsightly. In fall 2019, I started a pilot revegetation project. Instead of turf grass, I used native, wet-loving plants that soak up stormwater faster than turf grass, require less maintenance, and provide native amphibian and pollinator habitat. I partnered with the campus and students to begin revegetating the muddiest part of the basin with 60 plants. Unfortunately, being new to the process, I killed off most of the sedges through improper placement. 8 months later, and wiser, I planted 180 plugs. These lived. And here is the basin approximately 1 year into the project in late August 2020. Here is how our basin works as green infrastructure. At point A, the tall plants dissipate runoff energy and drop suspended sediments. At point B, the plant's long roots quickly infiltrate ponded water and take up excess nutrients. Soil microbes break down contaminants. At point C, cleaner groundwater moves down gradient toward our local stream, Tulpahawken Creek. At point D, the unmown native plants provide year-round wildlife habitat and beauty. Green infrastructure. I think that's it. Can you hear me?
We can. Yep. That was a great video.
Okay, great. All right, so I'm Janae Park Martinez, and I am the person spearheading the green infrastructure projects at Penn State Berks. And so, as probably everybody
may know, in the old days, the idea was to get stormwater off-site as soon as possible, which we learned causes or exacerbates downstream flooding and erosion and also surface water pollution. But even though we know better management practices now, a lot of that older infrastructure still exists.
Dr. Park-Martinez, sorry to interrupt. I think you may need to re-share your screen so we can get back to your slide presentation. We're just seeing blank now.
Okay, let's try that again. Sorry about that.
Don't worry about it, it's okay.
You stopped me though. Okay, so now we
see a screen, it's blue.
Okay, hold on a second. So let me figure out what I'm doing here. PowerPoint. Okay, how about now?
Looks good, thank you.
Okay, you see the full screen?
We do. Okay,
excellent. So let me just go back one. Okay, so this is me, Janae Park-Martinez. And so this was just talking about sort of old strategies to move stormwater off-site. But the reason I'm talking about this is because at Penn State Berks, where I am, we still have we have about 5 stormwater basins on campus, and some of them have infrastructure from sort of these older management practices, including like concrete trenches to move stormwater rapidly through the basin. Now, the basin that I'm talking about doesn't have that, but I have ambitions. So nowadays, we know that best management practices include keeping stormwater on site. And the reason for that is to slow the flow, which gives the soils and plants a chance to soak up the stormwater. And when the stormwater slows down, sediments fall out, and also slow flow allows plants and soils time to absorb and start to break down contaminants. So here's the basin that you saw in the video. The yellow box is around that muddy portion where I concentrated my efforts. It's about 480 square feet. So these are before and after pictures. The before picture was taken in the spring of 2019, and the after picture was taken in August of 2020. So the pictures span about 18 months, but the actual revegetation project took about 12 months, from fall of 19 to fall of 20. So when we started this project, we had the situation on the left where that muddy interior of the basin did not have anything growing there. The ponded water had killed the turf grass. So that really made it easy for us to revegetate. There was also less weeding initially, but I have to say it was very ugly. So we initially planted 60 plants, and 60 plants in 480 square feet looked underwhelming, let's say. But then in spring of 20, the turf grass started to recover. Probably it was propagating in from the sides. And so at that point, I needed to plug within the existing vegetation. So what I mean by that is I used, if you look in the lower right-hand corner, there's a little bulb planter. So I used that to make holes in the existing turf grass, and I transplanted little pint-sized plants called plugs into those holes. So there's good and bad parts about plugging into existing vegetation. One of the challenges is that because everything's growing at the same time, it can be hard to recognize what you planted, and you really, so I needed to learn what the different plants looked like when they were immature. And so that was a fun process. The aesthetics are much better plugging into existing vegetation, the public sees green and more green, as opposed to sort of a desolate landscape like they saw on the left. And the existing vegetation, even though it may not be ideal, it does help prevent erosion. So all those roots hold the soil down. And that's really helpful because when we started in the fall of 19, on the left, whenever we would have rain events, then all the silt would be picked up and moved around, and it would coat the leaves of our 60 little plants. In the spring, fortunately, because of the rebound of the vegetation, there was a lot less erosion, and also that helped with infiltration. So when you're deciding what plants to use in the basin, it is really important to know the normal basin conditions. And I said in the video, I messed this up initially. I was thinking stormwater basin, wet. Well, that's true sometimes, but actually our basin is in full light, full sunlight, and unless we've recently had a rain event, the moisture level is maybe medium. And then in the center, deepest part, maybe we have more moisture. We also had a lot of deer that regularly traversed the basin, and they even had a little trail right through the middle of it. So predation was something I had to take into account. I didn't want to plant a smorgasbord for the deer, and when the plants are young, they're very vulnerable. So we needed to put some fencing in place. So our initial planting was in the fall, and in the fall, those very economical plugs that I was talking about, the pint-sized plants, may be in short supply. So when you're thinking about planting, you may need to order plants. So the plugs are the least expensive. The nursery I used, plugs were about $2, quarts were about $5. We're talking quart-size plants. And gallon-size plants were $8 to $10. So it's true that larger plants are more expensive. However, they also establish faster and propagate faster. So you've got to decide your priorities. Our priorities were for economy, and so we primarily used plugs. This is just a slide to reiterate, you need to think about your typical conditions, not just rain event conditions. That said, the interior lowest part of the basin will have more moisture than the drier sides. If possible, it is nice to choose some plants that have longer roots. By long, I mean a meter or more. So in our basin, we have Indian grass and wild indigo, which both have long roots. For comparison, you can see the oval on the far left, that is turf grass. And there's an old rule of thumb that what you see above ground is what you get below ground. So if you're mowing turf grass at like 4 inches, then you may have about 4 inches of root below ground. So prior to this revegetation, that was what was planted in the basin. So longer roots do increase infiltration. They also have more biomass to store carbon. They support habitat for microbes, and so they can nourish the soil, especially if, so some of our plants, like the wild indigo, have bacteria that fix nitrogen, So now that just benefits the indigo, but it does allow those plants to live in poor soils like clays. It increases bioproductivity, allowing more habitat in the soil. And roots, of course, whether they're long or short, they help prevent erosion. I chose native plants for the basin, in part because they're already adapted to our climate, which should increase their survivorship. They're also multifunctional, and my plans for the basin are multifunctional, not just to infiltrate stormwater well, but also to use it as a living laboratory for my classes. So I was, happy about the idea that native plants would provide pollinator habitat, not just for insects, but also hummingbirds, and support beneficial insects. And by that, I mean not just pollinator insects, but also, for example, parasitoids, the insects that can parasitize pest insects, like think about aphids, for example. So almost all beneficial insects need nectar and pollen at some point in their life cycle. So having flowers in your basin is not just pretty, but they actually do a lot of work. I'm also hoping to establish amphibian habitat. As I said before, the basin is probably too dry for frogs and salamanders, but I am hoping to recruit some toads. Here is the plant list. The yellow font indicates those plants with long roots, 1 meter or more. And then the white font is for pollinator-friendly plants, which is most of what I planted. Signage was really important in our basin because it's not mowed. And so we started out with the sign on the right. There's 2 of those in the basin to tell people what was going on, that this was not a neglected area, but this was planned for. The other thing is that the basin is left to overwinter in its natural state. So there are standing stalks, there's leaf litter, and that all provides habitat for those beneficial insects that I talked about earlier. So it was really important to tell the public that this was, part of the plan. And especially because this basin is in the center of campus, so it's very high visibility. And the sign on left, which we got later, the color graphic, it's attractive, and it also tells more of a story. And here you can see where the signs are placed. The green metal signs are there on the fence, and then the color graphic is next to the sidewalk. Most people do stay on the sidewalk. That's that white corridor you see in the aerial photo. But if people do walk over to the basin to look at the flowers, for example, there are signs that tell them what's going on. As I said, this was sort of a shoestring budget project, and so that encouraged me to find partners. So of course, natural partners were my students, and I was using the basin as a living laboratory. So my students got to do things like divide iris, as you see in the picture. And this worked out great as a partnership with the campus, because the campus got some free labor. They provided the plants, we divided them, and then they let us have some. So that was a nice partnership. They also allowed us to use, they have a large walk-in cooler like you might see, think of a restaurant refrigerator. And we cold propagated a bunch of seeds that we saved. So we collected seeds, native wetland seeds. We collected them, and then we gave them a fake winter in this cooler. So we sowed the seeds in flats and watered the flats, covered them loosely, and then they sat in the cooler for 3 months to allow their seed coats to break down so they would germinate in the spring. And a lot of our native perennial plants need to have a winter. So this was the 180 plants that I planted in May of 2020. Unfortunately, we were in pandemic lockdown, so no students were able to plant with me at that time, but I'm looking forward to, utilizing the basin as a living laboratory, again, going forward. In terms of costs, the most significant cost in this project was by far the signage. So those 3 signs, 2 metal and 1 color graphic, were almost $1,000. The entire project was about $1,660, and I did not include labor. It was my labor and my students' labor. I did spend about 1.5 hours per week during the growing season, May through September, in the basin, either watering or weeding. but that was primarily because that was establishing those plants. Now that the plants are established, I don't water them unless, if we had like maybe 3 or 4 weeks without rain, then I would water the plants in the center of the basin just to protect our investment. The weeding is also something that that's not just when the plants are establishing. That's going to be an ongoing responsibility because the basin is so central. It's high visibility. It's really important that it look well maintained, and so the weeding is an ongoing responsibility. I would love to have any questions anyone may have.
Great, thanks for this presentation. If we could have folks pop any questions that you have for Dr. Park-Martinez into the chat, that would be wonderful. In terms of questions that I have, first of all, I love this project. And I'm wondering, you had a lot of student participation when it came to the planting. Did you happen to have a student help with the sign development, or is that something that you found a professional graphic designer for?
We used the university had an opinion on that. So for the graphic sign, we used the same company that they use for all their campus signs. So that was for the color graphic. I did not have student help with that. At that point, we were already in the pandemic and everything was chaotic. Let's just put it that way. So no, at that point, I didn't have student help, but that would be a great idea going forward, though. I like that idea.
Yeah, we definitely, for projects that I've worked on that are related to this, the signage is expensive for sure. So I was just wondering if, the school had a graphic design department, for future stuff, that could be a cool way to get them involved. So we have some questions. I think we do have questions in the chat. Let's see. I'm going to scroll back up and let's see, we'll start here. Have you notified the municipality where the campus is located that this BMP has been installed so that they can ID it for their permit? And did you have to go through any municipal permitting process for installation?
Okay, so we did notify the municipality. I gave them a plant list when we started this project. I had to attest that I wasn't changing the fundamental nature of the basin, which I wasn't. So I remember doing that. So Penn State Berks is not an MS4 permittee. And so there wasn't anything in terms of credits or permits that we had to do.
Okay, great. Next question, let's see. In places that require basins to be lined, how deep would you recommend designing lining to avoid plant rooting interference?
Okay, so I think you would definitely have to do some research on that, but I know I would, if it has to be lined, then I think you would need to stay away from woody species and just use herbaceous plants. And I would say, so I was surprised that Indian grass could grow to 1.5 meters. And so, we're talking like 8 feet. You can choose shorter rooted vegetation, and if you want a shallower liner. So I think you would have to just, think about that. It might be prohibitively expensive to have a really, really deep liner.
Okay. Let's see. This question, how can you control Japanese knotweed on the banks of streams?
So I weed a lot. And invasive species removal is, just something that is a constant maintenance task. And so when you've got a basin, what I'm trying to do right now is recruit more partners on campus, and encourage anyone that has, a green thumb to become involved with this project, because ideally we do hope to revegetate our other basins. And some of them do have standing water in them. So, invasives is just one of the many weeds that you have to contend with, and it's just an ongoing. So people have to learn what are the invasives, and then learn when it's best to pull them. Some you get rid of in the spring, some you definitely want to get rid of in the fall, so that the following spring is easier for you.
Well, and our next question is definitely related to this topic of weeding and it being, a challenge. Like, are you providing training people that, you may be recruiting, how do they know what's beneficial versus what you don't really want there? And then, well, I'll do the follow-up after you have a chance to answer that one about, training your volunteers.
Sure. So I'm very much learning as I'm going. I have, anybody who's gardened has made the mistake of pulling out the wrong plant, which is crushing, right? But I was out there with a grass book, actually in the spring of last year, because I was like, is this my grass? Is this what Indian grass looks like when it's a baby? I have no idea. And I had to just, do a bunch of self-education. And so I'm super looking forward to actually getting out there with, real live people again and working side by side to learn, this is because I don't want to get rid of volunteers that are useful, in the picture that you see in front of you, the white flower on the right is bone set, and that was a volunteer. And I'm very happy to have it there, but I did not plant that. And so, it would be a shame to pull that out of ignorance. So this is very much a learning process. Sometimes I just let things go until they flower so that I can get a positive ID on them.
Oh, that's interesting. So the white ones you didn't intentionally plant, but they were seeded by some of your wildlife visitors?
I'm guessing.
Oh, that's fun.
Yeah.
Okay, so the follow-up to that is, do the beneficial plants, such as the grasses, ever need to be cut as part of the maintenance thing to be able to continue to grow?
No, because I'm weeding. So I'm taking you could probably cut things in the early spring if you wanted to. Like if this were a much larger basin, it might be beneficial to set the mower fairly high and do a pass just to make sure that you're not, getting any volunteer woody stuff in there. So, for larger basins. But at present, no, it doesn't have to be mowed at all. And I'm trying to really encourage it as habitat. So I'm trying to keep machinery out.
Nice. Okay. So now we have another question that goes back to IDing plants. You said you were out there with the grasses book. So this question is, do you ever use an app to ID the plants or other resources? Like, do you look at PlantSnap?
I have not yet. I have an old phone. I need to replace my phone. But I have definitely, I'm old school. I've got a bunch of books. And so I've used those, but I have been with people who have had very good experiences with plant apps. I would just, I think it's also useful to just have a double check, before you pull something out. That's my only recommendation. Before you kill it, double check to make sure what you're really pulling out.
You could probably even make your own photo compilation, right? Just
definitely. And I'm hoping to have another kind of sign. Of course, I'm going to have to get the money for this, but I would love to have a sign that says like what's blooming now. And then I could switch out plates to explain, because people look at what's blooming and then just say, so here's what they are and here's their ecological significance. so that because people are naturally attracted to the basin when it's flowering.
I love that idea about switching out. I'm taking that one. That's a good one.
Absolutely. Please share if you guys have ideas for me of improvements. Let me know.
That's fantastic. So have you had any issues with vandalism or, other than predation? You definitely mentioned the deer. And given that it's on campus, I would imagine it's pretty well protected. I've seen some in residential areas where, kids love to play or pick flowers. Are you dealing with any sort of issues of intrusion or, people trying to be in the space?
So far, no, but I have to say it was a very weird year, right? So I started in fall 19 and the campus was full of students. It looked like a big muddy pit with a few plants in it. And then, in the spring we were on campus through through March. And then everybody went into lockdown. So far, no. I think actually you can barely see it. Those top two lines, above the rabbit fence, that is actually a fishing line. That's 30-pound fishing line. And I use that. That is my deer fence. Apparently, I learned from an ag extension, not Penn State, but a different ag extension, that deer don't see well, they don't see the same way humans see. They see well enough for what deer need to see. But you can use fishing line. They bump into it, and they don't see very well, so they're not sure how high it goes, and that deters them from trying to jump it. And I have to say that in all the time that since that's been up, I have never seen a hoof print in the basin, and it used to be a major thoroughfare.
And I am now putting fishing line all around my backyard.
Yeah, it also keeps the people out. So back to your question, have I had anybody in? No. And although you can easily climb through there, I also think it acts as a people deterrent.
Wow. Well, that's impressive. I think that's a good tip. I'm learning lots of things. About the root ball, you had a comment on one of your slides that larger root balls equal pollinator friendly. I wasn't sure what the nexus was. Could you explain that?
No, that's not what I meant. Here, let me go back. Let's see.
Maybe I misread it.
Is this
Yes.
No, I was
I see what you're saying. Okay.
Yeah, I was just kind of calling out who does what.
Okay, gotcha. I misread. Apologies. Thanks for clarifying.
No, absolutely. Happy to do that.
Well, we still have about 10 minutes. Does anybody else have any other questions? Have you been doing tours yet? Or you will be, it sounds like next year, taking students out there.
In the fall, we normally have like a fall fest, which is basically the same. It's just the counterpart of our Earth Fest in the spring. And we do a big sustainability festival. And so I'm very much looking forward to highlighting, all the different functions of this basin. And I'm also super looking forward to starting to do research in the basin. So basins, there are lots of substantiated claims about what revegetated basins do, but I would like to substantiate those claims in our basin. So, you can see in the back of the basin, it's mowed, it's still turf grass. And so we do have a comparison. So I would like to look at infiltration rates. I would like to look at, how the sediment drops out differently when it comes across the turf grass versus when it comes, hits the higher vegetation. There's just, all those claims that you see. I would just like to work with my students to actually collect evidence for what's going on in our basin. And then, then you get the added benefit of doing research with students. And I just think that could be really, really useful and marvelous. So I'm really looking forward to, now that we've got some, and looking at biodiversity, of course, look at a cubic meter on the turf grass, see what's alive, and look at it in the revegetated part, see what's alive, and look at different diversity indices and stuff like that. So I'm super looking forward to really sort of delving into the science of this and figuring out what's going on.
Well, and do you think there's a chance? I mean, you have things that are coming back in the basin, like, or volunteer plants, like you were saying. Do you think there's a chance there could be spread as well from this?
You mean, is this going to seed other areas? Is that what you're saying? Right. I'm sure it would try if it could, but it is complete turf grass in all directions around it, and it's mowed very regularly.
So nothing would have a chance to establish.
No, but what I am hoping is that as the plants really proliferate, I can start I can start propagating things. So after they become dormant in the fall, it looks like my cardinal grass or my cardinal flower there in red is going great guns. I can lift some of those plants and start transplanting them to other basins on campus. And that will also, this can then, instead of going to nurseries and spending money buying plants, we can just use our own plants. So
that's a really great idea.
It doesn't really get to reseed areas because the basins are fairly far apart, but they will be used.
Are you getting hummingbirds at your cardinal flowers?
Oh my goodness, yes. We had, when I was in the basin last summer, I haven't seen them this year yet, but in the basin last summer, we had 2 females that were squabbling over the cardinal flower. And they didn't care that I was there. And one would come in and sip, and then the other would chase it away. And it was just amazing. I tried to take so many pictures, and you can't see a hummingbird anywhere.
Oh, wow. I think that's what I love about those plants is I hear if you want hummers, those are the ones to go for.
Yes, they love them. They absolutely love them. And actually, they're primarily only pollinated by hummingbirds because the flower structure is really difficult for other insects to get in there.
Oh, I didn't realize that. That's a cool fact.
Yeah, so if we want to keep our cardinal flower going strong, we have to make sure that we protect our hummingbirds too.
That's awesome. What a great project. Well, I don't see any more questions in the chat, but maybe everyone could go into the chat and use their emojis to give Dr. Park-Martinez some appreciation for her time today and coming and sharing this very awesome project with us. We really appreciate your time. And we can't wait for you to come back and present on the findings of your research analysis.
Oh, I would love that. Yes, I'm super excited to get students involved in that.
Well, wonderful. Well, thank you so much. And thanks to everyone for joining us. I think at this point, we're going to go back to the plenary. We'll leave this session, go back to the plenary, and we'll do a wrap up, which is, always a nice way to cap off our time together. So thank you, everyone, and we will see you in the plenary.
Thank you.
Thanks so much.
Bye-bye.